Hello, welcome back to Squeeze Theorem, quite possibly the easiest theorem in all of mathematics here. All you have to do is literally regurgitate what I'm about to tell you. So the Squeeze Theorem has a basic premise. The Squeeze Theorem is a simple theorem that allows us to find the limit of an unknown function if we know it is sandwiched between two other functions. For example, let f of x be unknown. Let's say we don't know what f of x is. But we know that it's between the graphs of sine of x and cosine of x on the domain negative pi over 4 to positive pi over 4. What could we say about the x value, f of values of the function at x equals 0? Well, if we were to graph the sine function right here, well, sine starts at 0, kind of goes like this. You may remember sine looks like this. And cosine starts at 1. It kind of goes like so. What we want to know is, as x approaches 0, what happens to f of x? Well, as we get closer to 0 on either side, notice the values. The f of x, our unknown function, we're told is always in between it. So f of x, because it's always between them, as we get close to 0, f of x has to be between 0 and 1. We know that because it's squeezed or sandwiched between the two. If my pencil is squeezed between my fingers, no matter where my fingers go, it's always going to be squeezed between them. So it has to be between them. Sometimes we call the squeeze theorem or the between theorem or sandwich theorem if you're hungry. So we know, we can say, therefore, f of x is between 0 and 1. And that's what the squeeze theorem tells us. And it's really pretty easy to figure out. Now, there is kind of a problem here. We don't know anything about the function. The function may not be defined at 0. So since we don't know anything about the function, it could be undefined at 0. So therefore, we can't really look at values of it. We have to look at the limits, because we don't know anything about f of x if it's defined at 0 or not. So let's introduce the squeeze theorem. It says, the squeeze theorem says, if you have a function f of x between h of x and g of x. So let's see here. If I have some function, some crazy delicious function, let me redo that. So let's say we have two known functions. Let's say we have h of x and we have g of x, right? And here's some random x value. And all we know is that f of x has to be between them. So f of x can go kind of crazy. But what happens as it gets closer to where they meet? It's being squeezed into this little cauldron at this little point right here. I don't know. And it goes on. So what happens as f of x approaches x? Well, it's getting squeezed between h of x and g of x. So what would happen to the value at f of x? Well, at x. Well, as f of x gets closer to x, it's approaching the same values as h and g. And that's what this says. If f is between h and g, and if h approaches some constant L, g approaches some constant, then our function has to approach the same value. So let's see how this works. You have to show your work. On the AP, this is like worth 2 or 3 points. So you have to show your work. So let's see how it works here. We're given a function. We know f of x is between 5x plus 1 and x cubed plus 3. We want to evaluate the limit as x approaches 2. Now, the first thing we're going to do is we are going to say that looking at h and g, we're going to say that these functions are continuous. So we're going to say we're going to have to say our two known functions are continuous. So we're going to say 5x plus 1 and x cubed plus 3 are continuous. Next, we're going to take their limits. What is the limit as x approaches 2 of 5x plus 1? That's easy. It's 11. What's the limit as x approaches 2 of x cubed plus 3? And again, that's 11 as well. So because my known functions are both approaching 11, f of x is between them, so it also has to approach 11. So we can say our 3 dots, therefore, the limit as x approaches 2 of f of x must also equal 11, and this is going to be by the squeeze theorem. You have to do the following. 1, and you're going to hate this, I know it. You have to show that the functions are continuous. Just tell that they're continuous. You have to show your limits, and then you have to show by squeeze theorem as well. All right. Hope you guys enjoyed the video. I'll see you soon. Bye-bye.